Look up on a clear night, and you'll see more than just points of light. You'll see a tapestry woven from human imagination, fear, and wonder. For thousands of years, people all over the world have gazed at those same stars and planets, and what they saw wasn't just random specks of light. They saw stories. They saw dragons swallowing the sun, heroes immortalized in constellations, and rivers of souls flowing across the heavens. These celestial enigmas are more than just myths. They're a record of how we've tried to make sense of a universe that often feels too vast, too mysterious, to fully comprehend. And what's truly fascinating is that many of those ancient stories weren't just fantasies, they were early forms of science, born from careful observation and a deep desire to understand the world beyond our own. Today, we have telescopes that can peer billions of years into the past and probes that journey to the edge of our solar system. Yet the night sky hasn't lost its power to captivate us. If anything, science has only deepened the mystery. We now know that what the Greeks called the Milky Way is in fact the brilliant core of our galaxy, a swirling disk of billions of stars. We understand that eclipses aren't celestial battles but breathtaking alignments of the sun, moon, and earth. But knowing how something works doesn't strip away its magic, it adds to it. Because now, when we look up, we're not just seeing stories, we're seeing evidence of black holes, nebulae where stars are born, and planets that might harbor life. We're connecting the dots between the tales told by ancient cultures and the truths uncovered by modern astronomers. This video is an invitation to explore that beautiful intersection where myth and science meet, each enriching the other. Together, we'll travel across cultures and through time, from the star lore of indigenous Australians to the planetary names born from Roman gods. We'll uncover why certain stories endure, what they reveal about us as human beings, and how the same sky that inspired fear and reverence in our ancestors now fuels curiosity and discovery in our own era. By the end, you won't just see the night sky differently, you'll feel it. You'll understand that every time we look up, we're participating in a conversation that spans millennia, one that connects all of us under the same cosmic storybook. So let's begin this journey into the science, the stories, and the soul of the celestial enigma. What exactly makes a cosmic phenomenon into a myth? It begins with something that defies easy explanation: a sudden darkness at noon, a streak of light across the night sky, or the slow, wandering path of a bright star that doesn't behave like the others. These events are so visually striking and so far outside ordinary experience that they demand a story. They become what we call celestial enigmas, puzzles written in the language of the cosmos that every human culture, in its own way, has tried to solve. It's not just about the event itself, but the powerful reaction it provokes, a deep, humbling awe that mixes wonder with a touch of fear. This emotional response is the raw material from which myths are forged. Consider the simple act of an eclipse. For us, with our precise orbital mechanics and global alerts, it's a predictable celestial ballet, but imagine witnessing one without that knowledge. The sun, the very source of life and light, is suddenly and silently swallowed by an unseen force. The world plunges into an eerie twilight, birds stop singing, and the temperature drops. It feels apocalyptic. Is it any wonder that cultures from ancient China to the Vikings crafted stories of celestial dragons or wolves to explain this terrifying violation of the natural order? The myth isn't just a fanciful tale, it's a framework for processing a deeply unsettling experience. It provides a narrative where there was only chaos, offering both an explanation and a prescribed response, like banging pots and pans to scare the dragon away. This restores a sense of control in the face of the incomprehensible. This process reveals a fascinating duality in our relationship with the cosmos. On one hand, we are innate scientists, carefully observing and cataloging patterns. Ancient sky watchers noted the precise cycles of Venus or the predictable return of comets long before they understood their nature. On the other hand, we are storytellers, weaving those observations into the fabric of our beliefs, values, and identities. A grouping of stars isn't just a random scatter. It's a hunter, a bear, or a great canoe of ancestors forever immortalized in the heavens. The Milky Way isn't just a hazy band of light. It's a river of souls, a pathway for gods, or the spilled milk of a divine goddess. These stories are more than just explanations. They are cultural touchstones. They tell us what a society feared, what it valued, and how it saw its place in the grand scheme of existence. Ultimately, a celestial enigma is any phenomenon that lives in the space between observation and understanding. It's the gap between what we see and what we can prove, and into that gap flows the rich human impulse to tell a story. These myths were our first scientific hypotheses, our first attempts to model the universe using the best tools available: keen observation and powerful imagination. They represent humanity's enduring drive to not only make sense of the unknown but to connect with it on a deeply human level, transforming cold, distant points of light into a familiar, story-filled sky. Picture this: tens of thousands of years ago, a human stands on a vast, open plain under a sky utterly untouched by artificial light. There is no hum of electricity, no glow of cities on the horizon, only the profound silence of the ancient world and a breathtaking, overwhelming canopy of stars. This was the original laboratory, the first observatory. With nothing but their own eyes and an innate, powerful curiosity, our ancestors began a project of observation that would span generations. They weren't just stargazing, they were pattern-recognizing, meaning-making machines, and the sky was their most important text. They quickly learned that the cosmos was not a random, chaotic display. It had a rhythm, a predictable pulse that became deeply intertwined with their very survival. The most immediate and vital patterns were the cycles of the sun and moon. The sun's daily journey from east to west dictated the fundamental rhythm of life: wakefulness and sleep, activity and rest. But its longer journey was even more critical. They tracked where it rose and set on the horizon, noticing that these points shifted slowly over the months. The sun's highest arc in the summer meant long, warm days for hunting and gathering, while its low, weak path in winter signaled a time of scarcity and cold. This wasn't just astronomy, it was the first calendar, a celestial clock that dictated the migration of herds, the availability of plants, and the changing of the seasons. The moon, with its clear, monthly cycle of birth, death, and rebirth, provided a shorter, more intimate rhythm. Its waxing and waning became a way to mark time, to schedule ceremonies, and to tell stories about its seemingly magical ability to change shape and disappear entirely. But it was the fixed stars that offered the most stable map. Unlike the wandering planets, the stars returned to the same position night after night, season after season, with unwavering reliability. Early sky watchers began to connect these bright points into patterns: the first constellations. These weren't arbitrary drawings, they were mnemonic devices, a way to remember and track the movements of the celestial sphere. The constellation we call Orion, for instance, was seen by many cultures as a hunter. His appearance in the winter sky might have signaled that it was the prime time for hunting certain game, or a warning of the harsh cold to come. The Pleiades star cluster, a tiny, distinctive group of stars, served as a critical marker across the globe. In ancient Greece, its heliacal rising, its first appearance in the dawn sky after a period of invisibility, signaled the start of the sailing season. For the indigenous Australians, it was tied to the life cycle of a particular grub, indicating when it would be most plentiful for harvesting. For the Maori of New Zealand, it marked the new year. This was applied science, a direct and crucial link between celestial observation and earthly sustenance. With these practical observations firmly in place, the human impulse to storytell took over. The patterns in the stars were too evocative, too filled with potential drama to be mere calculators. Why does the moon vanish? A great frog or jaguar must be swallowing it, requiring shouts and noise to scare the creature away. Why does the sun cross the sky? It must be a god in a chariot or being carried across the heavens in a boat. The Aboriginal Dreamtime stories of Australia offer one of the most profound examples of this fusion. In this worldview, the landscape and the sky are not separate realms. The constellations are not merely pictures of ancestors. They are the ancestors, eternal beings who walked the earth during the dreaming and then ascended into the sky, their stories and laws encoded in the stars for all to remember. The emu in the sky, for example, isn't formed by the stars themselves but by the dark patches of interstellar dust within the Milky Way. Its position throughout the year tells observers about the emu's behavior on the ground, when it's nesting, when its eggs are ready, blending astrophysics, zoology, and sacred lore into a single, cohesive narrative. This incredible synthesis of careful observation and rich mythology was the bedrock upon which all later science was built. It was a sophisticated, systematic effort to understand the universe and humanity's place within it. These ancient myth-makers were the first philosophers and the first physicists, using the best tools they had, their senses and their imagination, to answer the biggest questions. They transformed the cold, impersonal void into a familiar, story-filled landscape, a place of gods, heroes, and ancestors. They gave the universe a narrative, and in doing so, they gave themselves a purpose within it. This foundational human need to find meaning in the patterns above us set the stage for an explosion of cultural interpretation, as societies across the globe looked upon the very same stars and saw reflections of their own unique worlds, values, and beliefs. This incredible diversity in celestial storytelling reveals a profound truth about humanity. We all share the same stage, the same cosmic backdrop, but we each write our own script. The sky is the ultimate Rorschach test, a vast ink blot onto which cultures project their deepest fears, highest aspirations, and most fundamental understandings of how the world works. The environment a society calls home fundamentally shapes its cosmic vision. For the ancient Egyptians, life itself depended on the annual, predictable flooding of the Nile. It was their heartbeat, so it's no surprise that their entire celestial system was geared toward anticipating this event. The heliacal rising of Sirius, when the star first becomes visible just before dawn after a period of absence, coincided perfectly with the Nile's inundation. They didn't just see a bright star, they saw Sopdet, a goddess whose tears of mourning for her husband Osiris were believed to cause the river to overflow, bringing fertile silt and life to the land. Their astronomy was a direct, practical tool for survival, deeply woven into their religious belief that the pharaoh, as a living god, maintained this cosmic order. Now travel across the world to ancient China, and you find a society with a completely different relationship with the heavens. Chinese astronomy was incredibly advanced, with court astronomers meticulously recording celestial events for centuries. But their focus was less on nourishing floods and more on maintaining social and political harmony. The sky was a mirror of the imperial court, and any unusual event, a comet, a nova, an eclipse, was seen as a direct message from heaven, often an omen criticizing the emperor's rule. A celestial disruption meant the emperor had lost the mandate of heaven, and it was his responsibility to correct his ways to restore balance. This turned astronomy into a state-controlled science, a means of upholding power and predicting the stability of the dynasty. The same star, Sirius, was part of a celestial asterism representing a large bow used to hunt the jackal like Tianlang, the heavenly wolf, reflecting a different set of concerns entirely. This pattern of local interpretation repeats everywhere we look. The constellation Orion is a perfect case study. To the ancient Greeks, he was a boastful, mighty hunter placed in the stars by Zeus, forever pursuing the Pleiades sisters across the heavens, a story of hubris and divine punishment. For the Norse, the same set of stars was known as Orwendil, a mighty warrior. One myth tells of the god Thor breaking off one of Orwendil's frozen toes and throwing it into the sky to become the star we call Alka, a tiny companion to the brighter Mizar in the handle of the Big Dipper. Meanwhile, for some Aboriginal groups in Australia, the stars of Orion's belt are not a hunter's waist but 3 young men in a canoe who went on a fateful journey to hunt a sacred kingfish, a story that carries deep moral and environmental lessons about respecting nature. One pattern, 3 completely different narratives, each reflecting the values and landscapes of its people. This cultural lens even extends to something as fundamental as the Milky Way. In many East Asian traditions, it was the Silvery River, a celestial barrier that separated the weaving maiden Jainu Vega from her cowherd husband New Lang Altair, allowing them to meet only once a year, a story that explains the stars' positions and sparks festivals celebrating love and reunion. For the Finns, it was the pathway of the birds, Linnunrota, as they observed migratory birds seeming to follow this glowing path south. The Cherokee people saw it as the trail where a dog stole cornmeal and was chased away, scattering the white powder across the sky. Each name, each story, is a window into a worldview. These myths were far more than simple entertainment. They were the vessels of knowledge, the frameworks of law, the maps for navigation, and the calendars for agriculture. They encoded critical survival information in a memorable, oral format long before the written word was common. By painting their gods, heroes, and animals across the night sky, ancient cultures transformed the overwhelming vastness of the cosmos into a familiar, meaningful, and deeply personal landscape, proving that while the stars are universal, the stories we tell about them are beautifully, uniquely human. Of all the celestial events that have captivated and terrified humanity throughout history, few can match the sheer, heart-stopping drama of a total solar eclipse. Imagine the scene, a bright, sunny day, life carrying on as usual when slowly, imperceptibly at first, a dark bite is taken out of the sun. The light begins to warp, casting long, strange shadows. The air chills, birds fall silent, confused into believing night has arrived prematurely. Then, in the final moments, day snaps into a surreal twilight. The sun is replaced by a perfect black hole in the sky, wreathed in an unearthly, shimmering silver halo. The solar corona. For those few precious minutes, the universe feels profoundly different, and it is no wonder that our ancestors believed the world was ending. This wasn't a spectacle to be enjoyed. It was an omen to be feared, a direct message from the gods, and often a sign of their immense displeasure. Cultures across the globe developed intricate myths to explain this terrifying violation of the natural order, and nearly all of them involved a monster. In ancient China, the culprit was a celestial dragon. The word for eclipse, shi, even means to eat, reflecting the belief that a great dragon was devouring the sun. The response was a cacophony of noise. People would bang drums, pots, and pans, and shout at the sky to scare the beast away. This ritual was so ingrained that it even found its way into official court records, where astronomers who failed to predict an eclipse could face severe punishment. For the Vikings, the threat came from a pair of monstrous wolves, Skull and Hati. Skull chased the sun while his brother Hati pursued the moon. An eclipse occurred whenever one of these wolves finally caught its prey. In ancient India, it was the decapitated, demonic head of Rahu that was to blame. According to the myth, Rahu had stolen a sip of the nectar of immortality and was beheaded by the god Vishnu. His head, now immortal, eternally flies across the sky, periodically swallowing the sun and moon out of revenge, only for them to fall out of his severed throat. These stories were far more than just creative fables. They were mechanisms for coping with the unknown and restoring a sense of control. The prescribed rituals, the loud noises, the prayers, the offerings, gave people an active role in fighting back the darkness and ensuring the sun's return. This was critical psychology. It transformed a population from helpless victims of a cosmic event into participants in a celestial battle. The success of these rituals, confirmed every time the sun inevitably reappeared, reinforced their power and cemented the myths into cultural tradition. The eclipse became a recurring drama of chaos and order, a story where humanity could play the hero. The great turning point, the moment the monster stories began to lose their grip, came with the slow, patient work of observation. Ancient Babylonian astronomers, meticulous record keepers, began to notice a pattern. They documented the Saros cycle, a period of approximately 18 years, 11 days, and 8 hours after which eclipses repeat themselves. They couldn't explain why it happened, but they could predict when it would happen. This was a monumental leap. It meant the gods weren't acting randomly, they were following a schedule. This knowledge was power. The Greek historian Herodotus even wrote that the philosopher Thales of Miletus used knowledge of this cycle to end a war between the Lydians and the Medes by predicting an eclipse, shocking the battling armies into a peace treaty. Today, of course, we understand the precise celestial mechanics. We know an eclipse is a breathtakingly precise alignment of the sun, moon, and earth, a cosmic coincidence where the moon's size and distance allow it to perfectly obscure the sun's disk. We can predict eclipses down to the second, centuries in advance. We no longer bang drums to scare away dragons. We book flights and hotel rooms to stand in the path of totality. But has this scientific understanding stripped the event of its magic? Quite the opposite. Knowing the mechanics only deepens the awe. We now use eclipses as unique scientific opportunities. The brief darkness allows us to study the sun's ethereal corona, its outer atmosphere that is normally drowned out by the blinding photosphere. It was during an eclipse in 1919 that observations of starlight bending around the sun confirmed Einstein's theory of general relativity, forever reshaping our understanding of gravity and the fabric of space-time. So, while we've traded dragons for physics, the emotional core of the experience remains powerfully intact. The sudden chill, the hushed world, the breathtaking diamond ring effect, these sensations connect us directly to every human who ever looked up in wonder and terror. We feel the same primal awe, but now it's layered with the profound wonder of comprehension. We are not fearing the end of the world, we are marveling at its exquisite order. This journey from omen to understanding is one of humanity's greatest triumphs, proving that we can replace fear with knowledge without losing an ounce of wonder. And just as eclipses taught us to read the sky's patterns, other, more unpredictable visitors would challenge our understanding in entirely different ways. If eclipses were the predictable monsters of the sky, Then comets were the ultimate wild cards, utterly unpredictable, shockingly bright, and appearing without warning to scribble their ominous message across the heavens. Unlike the orderly dance of the planets or the reliable cycles of the moon, a comet's arrival was a complete surprise, a breach of the celestial peace that could only mean one thing: change was coming, and it was rarely good. These long-haired stars, as the Greeks called them, were universally seen as harbingers, divine messengers whose appearance signaled turmoil, transition, and often tragedy. Their influence wasn't confined to myth. It actively shaped the course of human history, altering the decisions of kings and the fates of empires. In the ancient world, the link between comets and power was absolute. The Romans were particularly attuned to this connection. They believed the soul of a great leader ascended to become a star, and a comet was the most dramatic celestial endorsement imaginable. Perhaps the most famous example is the comet that appeared just months after the assassination of Julius Caesar in 44 BC. The Romans named it the Sidus Iulium, the Julian star. His adopted heir, Octavian, who would soon become the Emperor Augustus, seized on this phenomenon as powerful propaganda. He proclaimed the comet was nothing less than the soul of the deified Caesar taking his place among the gods, a clear sign that the gods favored his legacy and, by extension, Octavian himself. This wasn't just a story, it was a political tool that helped legitimize his rule and cement the end of the Republic and the rise of the Roman Empire. The comet's appearance was a historical pivot point, interpreted in a way that directly influenced the governance of the Western world. This view of comets as portents of doom only intensified in medieval Europe. With the rise of Christianity, their interpretation shifted from divine endorsement to divine punishment. The chaotic, unpredictable nature of comets fit perfectly into a world preoccupied with sin, apocalypse, and the wrath of God. When Halley's comet appeared in 1066, it was depicted in the Bayeux Tapestry as a star with fiery streams, hovering over a terrified King Harold II of England. The Anglo-Saxon Chronicle described it as a sign of wonder, and many saw it as an omen foretelling Harold's defeat and death at the hands of William the Conqueror just a few months later. Similarly, the appearance of a comet in 1347 was widely blamed for the Black Death that ravaged Europe, a visible sign of God's displeasure that heralded unimaginable suffering. The comet didn't cause the plague, but in the minds of people desperate for an explanation, it provided a terrifyingly simple cause for an otherwise incomprehensible catastrophe. But not every culture viewed these celestial visitors with fear. For many Native American tribes, meteors, those sudden, brilliant streaks of light we call shooting stars, held a deeply spiritual significance. Unlike the lingering dread of a comet, a meteor's brief, brilliant flash was often seen as a moment of profound connection. Some tribes interpreted them as the lights from the torches of celestial healers coming to Earth to gather sacred herbs. Others saw them as the spirits of ancestors, briefly visible as they traveled across the sky world. The Lakota people have a tradition of making a wish upon a meteor, believing it carries prayers directly to the spirit world. This perspective transforms a random piece of space rock burning up in the atmosphere into a sacred messenger, a fleeting but powerful link between the earthly and the divine. It's a beautiful counterpoint to the European narrative of dread, showing how the same phenomenon can inspire awe instead of terror, and connection instead of isolation. Today, of course, we have the science to demystify these visitors. We know comets are not fiery omens but dirty snowballs, ancient icy bodies left over from the formation of the solar system, originating in the distant Oort cloud. Their magnificent tails are not hair of fire but sunlight reflecting off gas and dust boiled away by the solar wind as they swing close to the sun. Meteors are simply tiny bits of comet or asteroid debris, often no larger than a pebble, vaporizing from friction as they slam into our atmosphere at tens of thousands of miles per hour. We can track their orbits, predict their returns, and even send spacecraft to rendezvous with them. Yet, even with all this knowledge, their power remains. The return of Halley's Comet in 1910 sparked widespread public panic fueled by sensationalist newspapers and the discovery of cyanogen gas in its tail, a fear that proved entirely unfounded. Its next appearance in 1986 was a global media event, a chance for a generation to witness a legend. And who hasn't felt a jolt of pure, childlike wonder at the unexpected flash of a meteor streaking through the night? Science has given us understanding, but it hasn't stripped away the awe. It has simply added new layers to the story, allowing us to appreciate not just the cultural drama, but the incredible cosmic journey these objects have undertaken. They are travelers from the deepest reaches of time and space, and whether we see them as harbingers, ancestors, or just beautiful physics, they continue to remind us that the universe is dynamic, unpredictable, and intimately connected to the human story. This deep connection between the movements of the heavens and the stories we tell about power and divinity finds its most enduring expression in the very names of the planets themselves. While the wandering stars we call planets now bear the names of Roman gods, their stories began long before the rise of Rome with the sharp-eyed astronomers of Mesopotamia. The Babylonians, meticulously tracking these celestial vagabonds against the fixed backdrop of stars, were the first to note their peculiar behavior and associate them with their own powerful deities. They saw the swift, elusive planet we call Mercury and named it Nabu after their god of wisdom and writing. The brilliant, beautiful Venus was Ishtar, the formidable goddess of love and war. The red planet Mars was Nergal, a fierce god of the underworld and pestilence. When the Greeks inherited this astronomical knowledge, they simply translated these divine associations into their own pantheon. Nabu became Hermes, the swift messenger of the gods. Ishtar became Aphrodite, the goddess of love. Nergal became Ares, the god of war. Later, as the torch of knowledge passed to the Romans, they completed the translation we use today, substituting their own gods for the Greek ones. Thus, Hermes became Mercury, Aphrodite became Venus, and Ares became Mars. This cultural and linguistic journey embedded a layer of ancient myth directly into the foundation of modern astronomy. The Roman names stuck because they were so perfectly suited to each planet's observed character. Take Mercury, for instance. It is the fastest moving planet in our sky, completing its orbit around the Sun in just 88 Earth days. It zips from being a morning star to an evening star with bewildering speed, often difficult to track. What better namesake than Mercury, the wing-footed messenger of the gods, known for his incredible speed and role as a communicator between divine realms. Then there is Venus, the brightest natural object in our night sky after the moon. Its dazzling, beautiful appearance made it an obvious candidate for the Roman goddess of love and beauty. But its character has a dual nature. From beneath its thick, cloudy atmosphere, surface temperatures are hot enough to melt lead, and its atmospheric pressure is crushing. This hidden, hostile environment echoes the more complex aspects of love and desire that the goddess Venus also represented, not just beauty, but also passion, jealousy, and power. The rusty red color of Mars immediately evoked blood and battle for ancient observers, leading them to name it after the Roman god of war. Its distinct hue, visible even to the naked eye, made it a terrifying and ominous sight. The Romans weren't alone in this martial connection. The Greeks saw their god Ares in it, and many other cultures also associated its red glow with conflict and fire. Jupiter, the largest planet in our solar system, demanded a name of equal grandeur. Its slow, majestic movement across the sky and its brilliant presence made it a king among the planets, so it was naturally named after Jupiter, the king of the Roman gods, the deity of thunder and the sky. Saturn, moving even more slowly and deliberately than Jupiter, was named after Jupiter's father, Saturn, the god of time and agriculture. Its gradual, plodding journey seemed to reflect the slow, inevitable passage of time itself. This system of naming based on mythological attributes wasn't limited to the planets visible to the naked eye. When William Herschel discovered a new planet beyond Saturn in 1781, he initially wanted to name it after King George III. Fortunately, the astronomical community prevailed, and they continued the tradition, reaching further into mythology. The new planet's cold, distant, and slow-moving nature led to it being named Uranus, after the Greek god of the sky and the heavens, the father of Saturn. Decades later, when mathematical predictions led to the discovery of yet another planet, the name Neptune was chosen for the blue gas giant, perfectly matching the Roman god of the sea. Even Pluto, though now reclassified as a dwarf planet, followed this pattern, named for the Roman god of the underworld, a fitting title for a small, cold world on the dark fringes of the solar system. This Greco-Roman framework, however, is just one chapter in a global story of planetary interpretation. In Hindu astrology and astronomy, the concept of the Navagrahas, or the 9 celestial influences, is central. These grahas include the Sun and Moon and the 5 classical planets, each associated with a specific deity and believed to exert a powerful influence on human destiny and earthly events. For example, Mars is Mangala, a god associated with energy, conflict, and strength. Jupiter is Brihaspati, the guru of the gods, representing wisdom, knowledge, and expansion. The Chinese astronomical tradition named the planets after the 5 fundamental elements of their philosophy. Venus is metal star, Jupiter is wood star, Mercury is water star, Mars is fire star, and Saturn is earth star. This system directly connected the movements of the cosmos to the fundamental building blocks of nature and the human body. These diverse systems of naming and interpretation reveal a universal human impulse. Before we understood planets as physical worlds with their own geology and atmospheres, we understood them as characters in a cosmic drama. Their movements told stories of divine messages, romantic pursuits, epic battles, and the slow turning of time's wheel. The myths provided a framework, a way to categorize and make sense of the complex dance overhead. They were the first theories of planetary science, attempts to explain why these particular points of light behaved differently from all the others. This rich tapestry of stories, woven from cultures across the globe, reminds us that our scientific understanding of the solar system is built upon a foundation of wonder, observation, and the timeless human need to find narrative in the night sky. Long before the written word, and even before the great myths of gods and heroes were fully formed, humans were doing something remarkable every clear night. They were connecting the dots. Gazing up at the overwhelming scatter of stars, our ancestors began to trace lines between the brightest points, creating the first constellations. This wasn't just an idle pastime, it was a fundamental act of creating order from chaos. By imposing familiar shapes onto the random patterns, they transformed the terrifying, infinite void into a manageable and meaningful storybook. These constellations became the world's first great epic tales, written not on parchment, but in light, and they were told and retold in countless languages under countless skies. Consider the most famous bear in the heavens, Ursa Major, the Great Bear. In Greek mythology, this sprawling constellation is the nymph Callisto, transformed into a bear by a jealous Hera and placed in the stars by her lover Zeus. But journey across the world to many indigenous cultures of North America, and you find a strikingly similar interpretation of those same 7 bright stars. To the Algonquin peoples, they are not the bear itself, but 3 hunters chasing a bear. The bowl of the Big Dipper represents the hunters, and the handle traces their path across the sky throughout the year. The story goes that the hunt begins in spring, and as the constellation climbs higher in the sky by autumn, the bear is eventually caught, and its blood is seen in the changing colors of the autumn leaves. This isn't a coincidence, it's a reflection of a shared human experience with a powerful, respected animal, viewed through different cultural lenses. One pattern, 2 profoundly different narratives, each perfectly suited to its people. These stories were far more than simple entertainment. They were the original user interface for the night sky, a practical technology for survival. For farmers, the heliacal rising of a constellation, its first appearance in the dawn sky after a period of being lost in the sun's glare, acted as an unerring agricultural alarm clock. The appearance of the Pleiades cluster might signal the time to plant or harvest. For sailors and desert travelers, constellations were a fixed map. The North Star, Polaris, which sits almost directly above Earth's North Pole, became the ultimate anchor point. Because all other stars appear to rotate around it, finding Polaris meant you could always determine true north. The Phoenicians, Vikings, and Polynesian navigators all relied on this celestial compass to traverse vast, featureless oceans, their voyages of exploration and trade guided by the immutable patterns overhead. This practical application reached its most complex form with the creation of the Zodiac. Ancient Babylonian astronomers divided the path of the sun, moon, and planets into 12 equal sections, each named after the constellation that appeared in that segment of the sky. This ecliptic path became a celestial highway, and the movement of heavenly bodies along it was used to mark the seasons and create precise calendars. Of course, these observations also gave birth to astrology, the belief that the positions of these celestial objects could influence human affairs. While science has long since separated from this belief system, the zodiac's enduring popularity shows the deep, timeless desire to feel connected to the cosmos, to believe that our personal stories are somehow written into the grandest story of all. The great reveal, the moment that changed our relationship with these patterns forever, came with the advancement of astronomy. We now know that the stars in a constellation are not a family, a hunting party, or a celestial beast gathered together. In most cases, they are vastly distant from one another, some relatively close to Earth and others thousands of light-years away. Their alignment is a complete illusion of perspective, a line-of-sight trick from our singular viewpoint on this planet. The hunter Orion, for example, is a collection of stars that have no physical relationship to each other. The brilliant Betelgeuse is a red supergiant on the brink of death over 600 light-years away, while the blue supergiant Rigel is about 860 light-years distant. They are cosmic strangers, forever frozen in a pattern that only makes sense from our tiny vantage point, and yet knowing this scientific truth hasn't dimmed their power one bit. We still teach children the names of the constellations. We still look up and instinctively see the shapes: the W of Cassiopeia, the scorpion of Scorpius, the great square of Pegasus. These patterns are a cultural inheritance, a shared language of the night that connects us to every human who has ever looked up in wonder. They remind us that our drive to find meaning and story is as constant as the stars themselves. This profound human need to not just observe but to explain and narrate the cosmos would eventually lead to a new kind of quest, one that moved beyond storytelling and began seeking physical laws to explain the magnificent clockwork of the heavens. This gradual shift from pure mythology to systematic observation marks one of humanity's most profound intellectual journeys, and it began not in a laboratory, but on clay tablets under the open sky. In the Fertile Crescent of Mesopotamia, the Babylonians became the world's first great data scientists. For centuries, their priest astronomers meticulously recorded the movements of the planets, the phases of the moon, and the timing of eclipses on thousands of cuneiform tablets. They weren't just watching, they were searching for patterns, believing that the gods communicated their will through celestial signs. This relentless logging of data led to astonishingly accurate predictive models. They identified the Saros cycle, which allowed them to forecast lunar eclipses, and created complex mathematical systems to describe the irregular motions of the planets. Their work was a powerful fusion of divine prophecy and rigorous mathematics, a crucial first step in treating the heavens as something that could be measured, calculated, and understood. Across the Mediterranean, Greek philosophers took this empirical data and infused it with a new desire for underlying physical principles. They began to ask not just when something would happen, but why. Figures like Aristotle argued for a universe of perfect crystalline spheres, with Earth sitting motionless at the center. This geocentric model, while ultimately incorrect, was a serious scientific attempt to explain the observed motions of the stars and planets within a logical, physical framework. The pinnacle of this Greek synthesis came with Claudius Ptolemy in the 2nd century. His monumental work, the Almagest, was a masterpiece of mathematical astronomy. To account for the planet's occasional retrograde motion, their apparent backwards loops in the sky, Ptolemy devised an ingenious system of epicycles, circles upon circles. It was complex and some might say contrived, but it worked with remarkable precision, allowing for accurate predictions that would stand unchallenged for over 1,000 years. His model, though deeply influenced by the philosophical idea of Earth's cosmic centrality, was a triumph of observation and mathematics over pure myth. While the Greco-Roman world flourished and eventually declined on the other side of the globe, another civilization was achieving its own breathtaking astronomical triumphs entirely independently. The Maya of Mesoamerica were arguably the most accomplished naked-eye astronomers in history. Their obsession with time led them to create calendars of mind-boggling precision. They tracked the cycles of Venus with fanatical accuracy, noting its appearances as the morning and evening star over a span of 584 days. They associated its movements with their feathered serpent god Kukulkan, believing its phases influenced the timing of war and coronations. Their sacred calendar, the Tzolk'in, interlocked with a solar calendar to form a calendar round that repeated every 52 years, a cycle central to their religious and civic life. Their observations were so precise that their calculated solar year was even more accurate than the Julian calendar used in Europe at the very same time. This was astronomy deeply enmeshed with culture and religion, yet built upon a foundation of relentless, precise observation. As Europe entered its so-called Dark Ages, the light of astronomical knowledge was kept burning by scholars in the Islamic world. In great centers of learning like Baghdad's House of Wisdom, translators preserved the works of Ptolemy, Aristotle, and other Greek thinkers, not just copying them but critically refining and expanding upon them. Astronomers like Al-Battani greatly improved measurements of the solar year and the precession of the equinoxes. Ibn al-Shatir, a 14th-century Damascene astronomer, developed planetary models that mathematically eliminated the need for Ptolemy's awkward equant point, a conceptual leap that would later influence Copernicus. Their sophisticated observatories and advanced instruments like the astrolabe and quadrant allowed for a level of precision that the Greeks never achieved. This golden age of Islamic science didn't just preserve ancient knowledge, It advanced it, creating the essential toolkit and the improved data that would eventually fuel the scientific revolution in Europe. What unites these diverse civilizations, the Babylonians, the Greeks, the Maya, and the Islamic scholars, is a shared, gradual transition in thinking. They began to move the primary explanation for celestial events from the direct, whimsical actions of gods to the predictable, mechanical workings of a system that could be described with mathematics and geometry. Mythology wasn't discarded, it was often the initial motivation. But over time, the emphasis shifted from telling stories about the gods to uncovering the rules that governed the cosmic machinery. This was the true dawn of astronomy, the slow, patient, collaborative effort to decode the sky, laying down a foundation of empirical data and theoretical models. This centuries-long project set the stage for a single invention that would shatter the ancient celestial spheres and forever change our place in the universe. In the year 1609, a curious professor in Padua did something that would forever fracture humanity's view of the cosmos. Galileo Galilei, hearing rumors of a Dutch invention that made distant objects appear close, crafted his own spyglass and did what no one had seriously considered doing before. He pointed it at the night sky. This simple act of turning a tool of terrestrial curiosity toward the heavens was a revolutionary one. He wasn't looking for gods or omens, he was just looking. And what he saw with that primitive, 20-power telescope shattered a worldview that had stood for nearly 2,000 years. The sky, he discovered, was not a perfect, unchanging vault of fixed stars as Aristotle and Ptolemy had taught. It was a dynamic, messy, and utterly surprising place. His first shocking revelation was the moon. According to the dominant Aristotelian view, the moon was a perfect, smooth, celestial sphere. But Galileo's telescope revealed a surface that was profoundly familiar and deeply imperfect. He saw mountains casting shadows, valleys, and craters, a landscape, he wrote, that looked remarkably like the Earth itself. This was heresy to the established order. It blurred the sacred line between the perfect, immutable heavens and the corrupt, changing Earth. If the moon was a world with geography, then perhaps the other planets were too. This single observation began to dismantle the very architecture of the ancient cosmos. Then he turned his attention to Jupiter. Over several nights in January 1610, he noticed 4 small, bright stars arranged in a straight line near the giant planet. Night after night, he watched, meticulously recording their positions. To his astonishment, they weren't fixed stars, they were moving, and they were moving with Jupiter. He realized he was witnessing 4 moons orbiting the planet, just as our moon orbits Earth. This was an absolutely devastating blow to the geocentric model. Aristotle's universe had everything revolving around Earth, yet here was clear, observable proof that not everything did. Jupiter, with its own miniature solar system, was a center of motion in itself. This provided powerful, tangible evidence for the Copernican idea that Earth was not the immovable center of all things. Perhaps his most clever and conclusive observation was of Venus. If the Ptolemaic system were correct, with Venus orbiting Earth on a small circle called an epicycle, it would always appear as a crescent when seen from Earth. But if Copernicus was right, with Venus orbiting the Sun, it should show a full set of phases just like our moon as it moved around its central star. Night after night, Galileo watched Venus. He saw it start as a small, full disk, then grow larger and wane to a crescent as it swung around the Sun. The complete cycle of phases was undeniable. Venus was orbiting the Sun. This was the kill shot for the Earth-centered universe. The evidence was now irrefutable. The planets were not mere points of light. They were other worlds, physically orbiting another center. Of course, this new knowledge did not arrive to universal applause. It landed like a bomb in the halls of power, both academic and religious. The idea that Earth was just another planet moving through space and not the focal point of God's creation was deeply threatening. It challenged scriptural interpretations and upended a comfortable, human-centric universe. Galileo, a devout Catholic himself, found himself in a brutal conflict with the church authorities who were wedded to a literal interpretation of the Bible that placed Earth firmly at the center. His subsequent trial and house arrest are a famous story of the tension between emerging scientific evidence and entrenched dogma, but his legacy was already secure. He had given humanity a new set of eyes. He didn't just propose a theory, he provided public, repeatable observations that anyone with a telescope could verify for themselves. He moved the conversation from philosophical debate into the realm of demonstrable evidence, forever changing the rules of how we understand our place in the cosmos. His work stands as an eternal testament to the power of looking for oneself and the courage required to report what you find, even when it contradicts everything you've been told. Galileo's telescope was a peephole into a new reality, but today's observatories have flung the doors wide open. We now operate a fleet of mechanical ambassadors and electronic eyes that have fundamentally rewritten our cosmic storybook. The Voyager probes, those twin pioneers launched in the late 1970s, became our first hands-on explorers. They didn't just photograph Jupiter and Saturn. They flew through their atmospheres of screaming winds and past their entourages of icy moons, transforming them from distant points of light into complex, dynamic worlds. Voyager's famous pale blue dot image, showing Earth as a mere speck of dust in a sunbeam, didn't just demystify our place in the cosmos, it delivered a profound philosophical punch, a visual echo of the humility that ancient myths often tried to impart through stories of gods and giants. Then came the Hubble Space Telescope, launched into orbit above Earth's blurring atmosphere. Its crystal-clear vision didn't just take pretty pictures, it conducted a forensic audit of the heavens. It peered into the heart of the Orion Nebula, a fuzzy patch in the hunter's sword long seen as a divine smudge, and revealed it for what it truly is, a chaotic, magnificent stellar nursery where suns are born from collapsing clouds of gas and dust, their fierce light sculpting pillars of creation. Hubble looked at the dim redness of Mars and showed us canyons that dwarf our own, evidence of ancient water flows, and polar ice caps, not a god of war, but a fossilized world with a complex and potentially habitable past. It trained its eye on Neptune, that distant blue world named for the sea god, and captured the swirling, Earth-sized tempests in its atmosphere, giving a violent meteorological reality to the mythological turbulence. The journey of discovery accelerated with a new generation of explorers. The New Horizons probe didn't just fly by Pluto, it delivered a postcard from the solar system's forgotten frontier, revealing a shockingly diverse world of nitrogen glaciers, water ice mountains, and a vast heart-shaped plain. The little world named for the god of the underworld was no longer a mere point of light, but a geologically active and breathtakingly beautiful place. Now the James Webb Space Telescope has taken up the watch, its infrared vision piercing through cosmic dust to see the universe's infancy. It's observing the very first galaxies forming, analyzing the atmospheres of distant exoplanets for signs of the building blocks of life, and looking into the nurseries of stars with even greater clarity than Hubble ever could. This flood of data has allowed us to perform a remarkable kind of historical reconciliation. We can now test the poetic impressions of our ancestors against hard data. The Romans saw Neptune as a volatile, moody god because the planet, from afar, appeared as a shifting blue speck. Our probes confirmed it is indeed a world of supersonic winds and violent storms. The mythology, in a way, was an astonishingly accurate metaphor born from limited observation. The ancient sky watchers who saw Venus as a beautiful goddess could never have imagined its surface is a hellscape of crushing pressure and acid rain, a truth revealed by landers like the Soviet Venera probes. The myths weren't wrong. They were a first draft, a narrative framework built on the best available evidence. Yet, far from stripping the universe of its mystery, this scientific revelation has only amplified its grandeur. Knowing that the Orion Nebula is a stellar nursery doesn't make it less divine. It makes it more awe-inspiring. Understanding the physics of a storm on Neptune doesn't diminish its power. It deepens our appreciation for the forces that shape worlds. We've traded the simple stories of capricious gods for the complex, emergent poetry of physical laws. A universe where gravity, nuclear fusion, and chemistry conspire to create beauty on an unimaginable scale. This marriage of technology and curiosity hasn't ended our wonder. It has given it an infinite new playground, proving that the truth is not only stranger than we imagined, but infinitely more magnificent. For all the brilliant light our telescopes and probes have shed on the cosmos, they have also illuminated the vast, dark frontiers of our ignorance. We have mapped the planets and measured the stars, yet we are forced to admit that most of the universe is made of stuff we cannot see, cannot touch, and do not understand. This is the modern celestial enigma, a puzzle that exists in the shadowy realm where hard data meets fundamental mystery, and where science, in its quest for answers, often finds itself speaking a language strangely reminiscent of myth. Consider the greatest cosmological mystery of our time, dark matter and dark energy. We know they must exist because of their overwhelming gravitational effects. Galaxies spin so fast they should fly apart, but an invisible gravitational glue or dark matter holds them together. Furthermore, the expansion of the universe is not slowing down as expected. It is accelerating, pushed apart by a mysterious repulsive force we call dark energy. Together, these two unseen components make up about 95% of the total mass energy of the entire cosmos. And yet, we have no idea what they actually are. They are invisible, undetectable by any instrument we have yet devised. They are the modern equivalents of the unseen gods and spirits that ancient cultures believed moved the sun and stars, powerful, omnipresent forces that govern the fate of the universe from behind a veil, their nature utterly unknown to us. We are like ancient sky watchers who could see the planets move and knew a power was guiding them, but could only give that power a name, not an explanation. Then there are black holes, those cosmic monsters that have completed their journey from mathematical speculation to confirmed reality. We have now photographed the shadow of one, a terrifying ring of light around a perfect circle of nothingness. Science describes them as regions of space-time where gravity is so intense that not even light can escape, but their properties are so extreme, so alien to our experience, that they naturally inspire mythic language. The point of no return, the event horizon, is described as a gateway to another reality, a one-way door from which there is no return. The singularity at their heart is a place where the laws of physics, as we know them, break down completely, a modern-day abyss, not unlike the primordial voids of creation myths like the Norse Ginnungagap. Are they portals? Are they monsters that devour stars? Our equations can describe their behavior, but they cannot fully convey their essence, leaving a gap that imagination rushes to fill with stories that are as much about philosophy as they are about physics. This same convergence of science and story fuels our longest-standing cosmic question: are we alone? The search for extraterrestrial intelligence, or SETI, is a rigorous scientific endeavor, using massive radio telescopes to scan the heavens for any artificial signal. It is grounded in the laws of probability and the science of astrobiology, and yet the cultural weight it carries is immense, tapping directly into humanity's oldest myths of otherworldly beings. Every culture has its stories of sky gods, star people, or celestial visitors, from the aboriginal Wandjina to the angels of Abrahamic traditions. The modern UFO phenomenon, while lacking scientific evidence, is a powerful continuation of this ancient narrative impulse, a desire for contact or a fear of the other. The scientific search for microbes on Mars or biosignatures in exoplanet atmospheres is a direct descendant of these myths. We are no longer looking for gods on Olympus, but we are using our most advanced tools to search for our cosmic cousins, driven by that same profound wonder about who else might be out there, looking back at the same stars. This is the beautiful, humbling truth of modern cosmology. Science has not eliminated mystery, it has simply given it a new, more precise vocabulary. We have traded tales of capricious gods for the confounding riddle of dark energy. We have replaced mythological beasts with the paradoxical nature of singularities. The enigma remains, but its nature has evolved. It is no longer a mystery of story, what narrative explains this event, but a mystery of mechanism, what physical law produces this effect. This shift does not make the universe less wondrous, it makes our pursuit more profound. We are now crafting new stories, not from fear and superstition, but from mathematics and curiosity, stories that are testable, falsifiable, and ever-evolving. The intersection of myth and science is where the next great discovery awaits. In Chinese letter, that some mysteries are not problems to be solved, but horizons to be explored. Stretching across the night sky like a luminous, ethereal scar, the Milky Way is perhaps the most universal and yet most personally interpreted celestial feature visible to the naked eye. Every human culture that has ever existed under a dark sky has gazed upon this hazy river of light and asked the same fundamental question: what is it? The answers they devised are a breathtaking testament to the diversity of human imagination, each story reflecting the unique environment, values, and spiritual beliefs of the people who told it. For the ancient Greeks, that soft glow was the result of a divine domestic accident. The myth tells that the infant Heracles was brought to the sleeping goddess Hera to drink her milk and thus gain immortality. When she awoke and pushed him away, her milk sprayed across the heavens, creating the galaxy. This story, which gives us the very name galaxy from the Greek gala, meaning milk, transforms a random astrophysical feature into a moment of profound mythological significance, linking the cosmos to the themes of divinity, nurture, and power. On the other side of the world, many indigenous cultures of the Americas saw not spilled milk, but a pathway. For the Cherokee, it was the trail of a dog who had stolen cornmeal and was chased away, scattering the white powder as he fled. For numerous other nations, including the Lakota, it was the road of souls or the spirit path. In this powerful interpretation, the Milky Way was the route that souls traveled after death on their journey to the afterlife. The brighter stars were campfires lighting the way, and the dark rifts within the band, which we now know are vast clouds of interstellar dust, were seen as a dangerous log that souls had to cross or a river within the river. This view integrated the celestial landscape directly into the cycle of life and death, offering comfort, meaning, and a cosmic map for the human spirit. Similarly, the Finns called it Linnanrata, the pathway of the birds, believing it was the migratory route that birds followed on their annual journey south, directly tying the heavens to the natural rhythms of their world. These ancient stories were humanity's first cosmological models, born from brilliant naked eye observation. What they were seeing, though they couldn't know it, was the combined light of hundreds of billions of stars that make up the disk of our home galaxy, a barred spiral we call the Milky Way. Our solar system is embedded within one of its spiral arms, about 27,000 light-years from the center. From our vantage point inside this vast frisbee of stars, we look out through the plane of the disk, and the sheer density of stars in our line of sight creates that familiar cloudy band arching overhead. The true nature of this structure was one of astronomy's greatest puzzles until the early 20th century, when astronomers like Harlow Shapley and Edwin Hubble began to measure the size and shape of our galaxy and prove that those faint spiral nebulae in the sky were other island universes entirely, galaxies in their own right. The scientific revelation that the Milky Way is a galaxy among trillions and that our Sun is a single, ordinary star on its outskirts could be seen as a demotion from our place at the center of a divine creation. But in reality, it is a promotion into a universe of unimaginable grandeur. We now understand the galactic core, hidden from our view by those same dust clouds that featured in indigenous myths, to be a seething, energetic region dominated by a supermassive black hole named Sagittarius A, with a mass 4 million times that of our Sun. The graceful spiral arms are not static structures but density waves, triggering the birth of new stars as they rotate. This scientific understanding is every bit as awe-inspiring as the myths, revealing a dynamic, violent, and beautiful cosmic engine. The magic lies in the fact that the scientific story does not invalidate the ancient ones, it coexists with them. When we look at the Milky Way today, we can hold both truths in our mind at once. We can see the river of souls and the spilled milk of a goddess, while also understanding we are looking at the combined light of countless suns and the central bulge of our galactic home. This dual vision enriches the experience, connecting us to the wonder of our ancestors while allowing us to appreciate the profound knowledge we have gained. The Milky Way remains the ultimate bridge between the intuitive, story-driven human mind and the analytical, evidence-seeking scientific spirit, a permanent fixture in our sky that continues to invite both poetry and physics, proving that some mysteries are so profound they require every tool we have to even begin to comprehend them. The human imagination has always been fascinated by the concept of nothingness, a terrifying void that swallows all light and matter. Long before Albert Einstein's equations predicted their existence, cultures around the world were telling stories about cosmic abysses. In Norse mythology, there was Ginnungagap, the great primordial void that existed before creation, a yawning chasm of pure potential and emptiness. Hindu cosmology speaks of pralaya, a periodic dissolution of the universe where all existence is reabsorbed into a state of latent potentiality, a cyclical consumption by the void. These ancient narratives grappled with the same terrifying concept that modern science now confronts, a point of infinite density and gravity from which nothing, not even light, can escape. It seems the human psyche has always understood, on an intuitive level, that the universe contains extremes of nothingness that defy all conventional experience. The journey from mythological concept to scientific reality began not with a telescope but with a pen. In 1915, Einstein published his theory of general relativity, which proposed that gravity is not a force but a warping of spacetime by mass and energy. Just a year later, physicist Karl Schwarzschild found a solution to Einstein's complex equations that described a point of such extreme density that it would warp spacetime into a closed pocket, a one-way street from which there is no return. For decades, these objects were considered mathematical curiosities, theoretical ghosts that were fascinating to ponder but unlikely to actually exist. Even Einstein himself doubted their physical reality. The term black hole wouldn't even be coined until the 1960s by physicist John Archibald Wheeler. The idea was so outlandish it seemed to belong more to the realm of philosophy or myth than to hard science. Then the evidence started to trickle in. Astronomers began detecting incredibly powerful sources of X-rays out in space, such as the system Cygnus X1. The only explanation that fit the data was that these emissions were coming from superheated gas being ripped from a companion star and spiraling at near light speed into an invisible object of tremendous mass, a black hole. The first direct visual proof came in April 2019, when the Event Horizon Telescope collaboration released an image that stunned the world. It wasn't a picture of the black hole itself, but of its shadow, a perfect fiery ring of light encircling a mesmerizing, dark emptiness at the heart of the galaxy Messier 87. This haunting image, the result of synchronizing radio telescopes across the globe to create an Earth-sized virtual observatory, was humanity's first direct glimpse of the event horizon, the point of no return. Myth had finally met its match in a photograph. We now understand black holes as natural endpoints in the life cycle of the most massive stars. When such a star exhausts its nuclear fuel, its outward radiation pressure can no longer counter the immense inward crush of its own gravity. The core collapses catastrophically in a supernova explosion, and if the remaining core is more than about 3 times the mass of our Sun, nothing can stop the collapse. It shrinks down to an infinitely dense point, a singularity wrapped in an invisible boundary called the event horizon. The strength of their gravity is almost impossible to comprehend. To escape a black hole's pull, you would need to travel faster than the speed of light, the universe's ultimate speed limit. They are not cosmic vacuum cleaners, randomly sucking in everything around them, but rather like a deep well in space. If you stay a safe distance away, you can orbit one perfectly normally, but if you cross the event horizon, your fate is sealed. What makes black holes so perpetually fascinating and so deeply mythic is what lies beyond that horizon. The singularity is a place where the laws of physics, as we know them, break down completely. Concepts of time, space, and matter cease to have any meaning we can understand. This is the modern Ginnungagap, a realm of pure mystery that sparks our imagination just as powerfully as any ancient tale. They have become potent metaphors in our culture for depression, for obsession, for the unknown, or for any point of no return. Scientists like Stephen Hawking added further layers of wonder with concepts like Hawking radiation, a theoretical process by which black holes can slowly evaporate over astronomical timescales, connecting them to the fields of quantum mechanics and thermodynamics. Our exploration of these objects is far from over, with gravitational wave observatories now detecting the ripples in spacetime caused by black holes colliding, each event a silent, cosmic thunderclap that reveals more about these dark hearts. They stand as the ultimate testament to the fact that some truths about our universe are, and may always be, stranger than any fiction we could invent. To the naked eye, a nebula is little more than a faint, fuzzy smudge against the dark velvet of the night sky, a subtle imperfection in the perfect pinpoint scatter of stars. But to the human imagination, that faint glow was a canvas waiting for a story. For the Maori people of Aotearoa, New Zealand, the 2 most prominent of these smudges, known to Western astronomy as the Large and Small Magellanic Clouds, were anything but clouds. They were Te Punga o Te Waka o Tamareti, the anchor stone of Tamareti's canoe. According to their tradition, the great navigator Tamareti sailed his waka, or canoe, across the celestial ocean, and to secure it in place, he used the bright star Sirius as its anchor point and the Magellanic Clouds as the sacred anchor stone. This wasn't just a charming tale. It was a cosmic map that connected their seafaring culture directly to the heavens, embedding critical navigational knowledge within a powerful creation story. Across the world, other cultures saw these ethereal glows as divine breath, the smoke from celestial campfires, or the shimmering spirits of ancestors watching over them from the sky. The true nature of these cosmic clouds remained one of astronomy's greatest mysteries for centuries. Even with the advent of telescopes, their faint, diffuse light was difficult to decipher. In the 18th century, astronomer Charles Messier, hunting for comets, grew so frustrated by these fixed, fuzzy objects that could be mistaken for his prey that he catalogued them as nuisances to be avoided. His list, which included now famous nebulae like the Crab and the Orion Nebula, ironically became a treasure map for future astronomers. The great debate of the early 20th century centered on these nebulae. Were they relatively small, nearby clouds of gas within our own Milky Way, or were they, as some suspected, island universes, distant galaxies in their own right? It wasn't until Edwin Hubble's observations in the 1920s, using the powerful Hooker telescope, that the truth was finally revealed. By identifying a special type of star within the Andromeda Nebula, he proved it was actually a galaxy millions of light-years away, vast beyond comprehension. Suddenly, the universe expanded overnight, and our understanding of nebulae split into two distinct categories. We now know that most nebulae are indeed immense clouds of gas and dust within our own galaxy, cosmic nurseries and tombs on a scale that defies human analogy. These are the places where the very stuff of stars is forged and recycled. An emission nebula, like the magnificent Orion Nebula, is a stellar nursery, a vast cloud of primarily hydrogen gas that is being illuminated and ionized by the fierce ultraviolet radiation from newborn, massive stars within it. This process causes the gas to glow in stunning shades of red, pink, and purple, the specific colors acting as a chemical fingerprint of the elements present. In contrast, a reflection nebula, like the delicate blue haze surrounding the Pleiades star cluster, contains no internal light source. Instead, it is a cloud of fine dust particles that simply reflects the light of nearby stars, much like fog around a street lamp. Then there are the dark nebulae, the ghosts of the cosmos. These are cold, dense clouds of gas and dust so thick they blot out the light from the stars behind them, creating dramatic silhouettes against the brighter Milky Way. The Horsehead Nebula is a famous example, a celestial chess piece carved from darkness itself. Perhaps the most poignant and powerful type of nebula is the Planetary Nebula, a name that is a complete misnomer from a time when their round shapes resembled distant planets through small telescopes. These are not the birth of stars, but their beautiful, violent deaths. When a star like our Sun exhausts its nuclear fuel, it doesn't explode. It gracefully sheds its outer layers into space over thousands of years. The exposed, hot core of the star then floods this expanding shell of gas with ultraviolet radiation, causing it to fluoresce in a brilliant, short-lived display. The Ring Nebula and the Helix Nebula are stunning examples, gigantic, glowing jewels hanging in space, the final exhalation of a dying sun. This process is the ultimate act of cosmic recycling, seeding the interstellar medium with heavy elements like carbon, oxygen, and nitrogen, the very elements that form planets and are essential for life as we know it. We are literally made of the dust from long-dead stars. This scientific understanding finds a profound echo in one of history's most famous celestial events. In July 1054, Chinese and Arabic astronomers recorded the sudden appearance of a guest star in the constellation Taurus. It was so bright it was visible in the daytime for weeks, a terrifying and unprecedented omen. We now know they witnessed a supernova, the catastrophic explosion of a massive star. Centuries later, astronomers using powerful telescopes pointed at that same patch of sky discovered not a star, but an expanding, filamentary cloud of gas, the Crab Nebula. At its heart lies a pulsar, the rapidly spinning, ultra-dense corpse of the original star, beating out pulses of radiation like a cosmic lighthouse. The Crab Nebula is the perfect bridge between myth and science. It is the physical remnant of an event that was once viewed with awe and fear, now understood as a fundamental engine of creation. The same event that inspired ancient omens is today a laboratory for studying the laws of physics under extreme conditions. This transformation in perspective doesn't diminish the nebula's power, it magnifies it. We can now look upon these clouds and see not just ancestral spirits or divine smoke, but the breathtaking cycle of cosmic life and death, itself a cycle of constant transformation that is both physically true and spiritually resonant, connecting the stories of our past to the very elements that flow through our veins. The course of human history has often been written in the stars, not as a matter of fate, but through the powerful lens of interpretation. Leaders and populations alike have looked to the heavens for guidance, for warning, and for validation, allowing celestial events to become pivotal catalysts that altered the destinies of nations. Perhaps no single year demonstrates this more powerfully than 1066, as William, Duke of Normandy, prepared his audacious invasion of England. A brilliant comet suddenly blazed across the sky. To modern eyes, it was Halley's Comet making its regular, predictable return, but to the people of the 11th century, it was an unmistakable omen. William and his forces saw it as a divine endorsement, a celestial sword in the sky blessing their campaign and foretelling their victory. The Anglo-Saxons under King Harold, however, interpreted the very same sign as a portent of disaster and divine wrath. This psychological warfare, waged with light and myth, was so potent that William later had the comet embroidered into the Bayeux Tapestry, a permanent piece of propaganda memorializing the notion that heaven itself had sanctioned his conquest and his new title as William the Conqueror. The comet didn't change the outcome of the battle, but it profoundly shaped the morale and perception of both sides, demonstrating how a random cosmic event could be woven into the narrative of power. Centuries later, another celestial visitor would challenge not a kingdom but an entire worldview. In 1572, a new star, brighter than Venus, appeared in the constellation Cassiopeia and remained visible for nearly 2 years. This was no comet but a supernova, the violent death of a distant star. A young Danish nobleman named Tycho Brahe meticulously observed this stellar nova, and his precise measurements proved it was located far beyond the moon, in the celestial realm that Aristotle had declared was perfect, unchanging, and immutable. This one event, witnessed across Europe and documented in countless pamphlets, shattered a cornerstone of classical philosophy that had stood for nearly 2,000 years. The supernova of 1572 didn't just light up the night sky, it ignited a scientific revolution. It forced astronomers like Brahe and later Kepler to accept that the heavens could change, that new things could appear, and that the universe was a dynamic, evolving place. This single point of light became a key piece of evidence that would eventually dismantle the geocentric model, proving that the sky could actively force a revolution in human thought. This relationship between celestial aspiration and earthly power reached its modern apex in the 20th century with the space race. While the Apollo moon landings were undoubtedly a geopolitical gambit in the Cold War, a technological showdown between the United States and the Soviet Union, they were also the culmination of millennia of human myth and longing. For thousands of years, the moon had been a goddess, a celestial orb, a destination for dreamers and writers like Lucian of Samosata and Jules Verne. The act of landing astronauts on its surface was a feat of immense political and scientific calculation, but it was also a profound cultural and almost spiritual achievement. It represented the moment when a species that had once told stories about the moon finally went there, transforming a celestial object from a distant symbol into a place that could be visited, studied, and walked upon. The political rivalry provided the funding and the urgency, but the deep, mythic human desire to touch the sky provided the enduring inspiration. This fusion of Cold War pragmatism and ancient wonder shows how our relationship with the cosmos operates on multiple levels simultaneously: the political, the scientific, and the deeply mythological. From the omen that secured a crown to the exploding star that shattered a philosophical paradigm and the lunar voyage that fulfilled an ancient dream, these events reveal a consistent truth. The sky has never been a passive backdrop to human history. It is an active participant, a screen onto which we project our fears and ambitions, and a physical reality that occasionally intervenes to reshape our understanding of the universe and our place within it. The interpretation of these events, whether as divine signs or natural phenomena, has repeatedly altered the decisions of kings, the funding of scientists, and the ambitions of nations, proving that our story is inextricably linked to the cosmos above. This deep-seated need to find meaning in the movement of the heavens forms the very foundation of one of humanity's most enduring and controversial practices, a system that claims to read our individual fates in the precise alignment of the planets. For thousands of years, the study of the sky was a single, unified pursuit. The same Babylonian priests who meticulously tracked the path of Venus to predict the movements of kings were also laying the foundational mathematics of orbital mechanics. In ancient Greece, the line between astronomer and astrologer was virtually non-existent. Ptolemy, whose geocentric model of the universe stood for over a millennium, also authored the Tetrabiblos, a 4-volume treatise on astrology that was considered a serious work of its time. The core idea was simple and compelling. The macrocosm of the heavens was directly connected to the microcosm of human life. The planets, named after powerful gods, must therefore exert a powerful influence on earthly events, from the fate of empires to the temperament of a newborn child. This system, born from careful observation and a desire to find meaningful patterns, was the unquestioned framework for understanding the cosmos and our place within it for the majority of human history. The great divorce between these two worldviews began not with a single event, but with a slow, seismic shift in thinking during the scientific revolution. As astronomers like Copernicus, Kepler, and Galileo gathered evidence for a sun-centered solar system governed by physical laws, the mystical link between the celestial and the terrestrial began to fray. Kepler himself, who discovered the elliptical orbits of the planets, also cast horoscopes for patrons, but he was deeply conflicted, searching in vain for a physical mechanism, perhaps a tidal force or a magnetic influence by which the planets could affect human affairs. He never found one. This was the crucial fork in the road. Astronomy began to demand testable hypotheses, reproducible evidence, and mathematical rigor. It asked how the planets moved, and its tools were the telescope, the clock, and the equation. Astrology, on the other hand, remained focused on why things happened to us, and its tools were symbolism, tradition, and interpretation. One sought to understand the universe on its own terms, the other sought to understand the universe in terms of us. This divergence created a fundamental difference in how each field responds to new information. When astronomy discovered new planets like Uranus, Neptune, and Pluto, it simply added them to the map of the solar system and refined its gravitational models. Astrology, however, faced a conceptual crisis. Did these new planets rule new signs? How did they fit into the existing symbolic system that was built around 7 celestial bodies? The answers varied, often depending on the astrologer, demonstrating a flexibility that is alien to the hard sciences. Furthermore, the very precession of the equinoxes, a slow wobble in Earth's axis, first documented by Hipparchus, means that the zodiac signs have drifted almost a full month from the actual constellations they were named after. Most Western astrology sidesteps this astronomical reality entirely, adhering to a symbolic, calendar-based system rather than the actual starry sky overhead. This highlights a key distinction. Astronomy is bound by physical reality, while astrology is bound by a self-contained system of meaning. Yet, to dismiss astrology as mere superstition is to miss its profound and enduring cultural function. In the modern world, it has largely shed its claims to predictive power over specific events and evolved into a language of introspection and psychology. For many, reading a horoscope is not about learning what will happen, but about engaging in a moment of self-reflection. The archetypes of the signs, the ambitious Capricorn, the communicative Gemini, provide a framework for contemplating one's own strengths, weaknesses, and potential. It offers narrative comfort in a complex and often chaotic world, creating a sense of order and personal connection to the vast, impersonal cosmos. Its booming popularity in apps and social media speaks to a deep, unmet need for meaning and community that cold, hard scientific facts, for all their truth, do not provide. It fulfills a mythological and psychological hunger. So, while astronomy and astrology now operate in completely separate realms, one a respected natural science, the other a vibrant cultural artifact, they both spring from the same deep human wellspring, our innate desire to look up at the starry sky and feel that we belong to it. One has given us GPS, space probes, and the age of the universe. The other gives us a vocabulary for our inner lives. They are two different answers to two different kinds of questions, proving that the human relationship with the cosmos is not a single path, but a spectrum of wonder that spans from the rigorously empirical to the deeply personal. This enduring power of celestial storytelling to shape our inner world finds its oldest and most resilient form not in books or apps, but in the ancient practice of sharing knowledge aloud around a fire under the very stars being discussed. Imagine a vast library, but with no books, no scrolls, no written words of any kind. This was the reality for countless human cultures, and their solution to preserving knowledge was one of incredible elegance and durability. The human voice, trained through ritual and repetition to carry entire worldviews across generations. Oral traditions were far more than just stories told around a campfire for entertainment. They were sophisticated, living databases, meticulously designed to encode vital information about the world in a format that was both unforgettable and portable. The night sky, with its predictable cycles and dramatic events, was a primary subject of this oral archive. The timing of the seasons, the appearance of certain stars, the rare and terrifying eclipse, these were not abstract facts. They were matters of survival, and they were woven into the very fabric of cultural memory through song, story, and ceremony. One of the most profound examples of this is the Aboriginal Australian concept of songlines or dreaming tracks. A songline is an oral map of the landscape, but it is also a creation story, a legal document, and a celestial navigation chart, all sung into existence. As an elder walks across the land, they sing the songs that describe the features they see, that mountain, that river bend, that specific tree, and crucially, they also sing the stars above that correspond to that place on the ground. The song doesn't just describe the physical world, it connects it directly to the celestial one. The journey of an ancestral being across the land is mirrored by a constellation's path across the sky. To know the song is to be able to navigate vast, featureless deserts by day using the earthly landmarks, and by night using the star maps encoded in the verses. The songline for the emu in the sky, for instance, isn't just about the dark shape in the Milky Way. It is intricately linked to the behavior of real emus on the ground, their breeding cycles, and the laws surrounding their hunting. The science of animal behavior and the calendar of the seasons are stored within the myth, ensuring the knowledge is passed on not as a dry list of facts, but as a living, sung narrative that is re-performed with every journey. This method of storing knowledge in story form is incredibly effective from a cognitive standpoint. Information that is embedded in a narrative structure, set to rhythm and rhyme, is far easier to memorize and recall accurately than a simple list of data. The ritualistic nature of its transmission, only certain people could learn certain songs, and only at the right time of year or stage of life, acted as a quality control mechanism, preventing the corruption of the information over centuries. We see this same principle at work in other cultures. The Norse peoples used alliterative verse and complex poetic meters to record everything from genealogies to laws, making them easier to remember. Polynesian navigators who undertook the most daring open ocean voyages in human history without any instruments learned vast mental star compasses. They memorized the rising and setting points of hundreds of stars, the patterns of ocean swells, and the flight paths of birds. All this knowledge was passed down through chants and oral teachings from master to apprentice. The star path of the birds, which we know as the Milky Way, was a key part of this navigational lore. The tragic reality of the modern world is that these intricate oral libraries are disappearing at an alarming rate. As elders pass away without teaching their songs to a generation increasingly disconnected from traditional ways, millennia of accumulated wisdom can vanish in a single lifetime. This has spurred urgent efforts by anthropologists and linguists, often working in partnership with indigenous communities, to document and preserve these traditions before they are lost forever. What these efforts are revealing is nothing short of astonishing. They are finding that these stories often contain hyper-accurate observations that have been preserved for longer than most written records have existed. There are Aboriginal stories that describe the coastline from a time when sea levels were significantly lower, over 7,000 years ago. There are Native American tales that recount the eruption of Mount Mazama to form Crater Lake, an event that occurred over 7,700 years ago. These aren't vague legends, they are eyewitness accounts fossilized in narrative and passed down through hundreds of generations. This loss is not just a cultural tragedy, it is a scientific one. We are only just beginning to appreciate the depth of the data encoded in these oral traditions, data that can provide invaluable insights into long-term environmental change, astronomy, and geology. The stories were the vessel, but the cargo was often precise, empirical observation. This process of modern science slowly, and sometimes accidentally, confirming the truths within ancient oral knowledge forces a humbling recognition. It challenges the arrogant notion that pre-literate societies were unscientific or that their myths were mere fantasies. Instead, it reveals them to have been keen, systematic observers of their world, who developed a brilliant and robust technology, the spoken word, to ensure their discoveries would never be forgotten. This reconciliation between the oldest forms of knowledge and the newest forms of inquiry opens up a fascinating new chapter, one where we must look back to the stories of the past to better understand the truths they have held all along. It's a humbling and thrilling moment when a story told for thousands of years around a campfire is suddenly illuminated by the cold, hard light of modern science. We often assume that myth and fact exist on opposite ends of the spectrum, but sometimes they meet in the middle, revealing that our ancestors were not just storytellers, they were keen observers who encoded their most critical discoveries in the only format guaranteed to survive: narrative. These aren't just coincidences, they are evidence of a deep, empirical wisdom preserved across countless generations, waiting for us to develop the tools to understand what they had known all along. Consider the vast coastline of Australia. For generations, Aboriginal communities have told stories about stretches of land that were once exposed, now submerged under the sea. They speak of ancient river systems, freshwater springs, and hunting grounds that now lie beneath the waves. For a long time, these were considered beautiful, symbolic legends. Then came the field of paleogeography, which maps past landscapes. Scientists began studying sea level rise since the last glacial maximum, around 20,000 years ago, when vast amounts of water were locked up in ice sheets and sea levels were over 120 meters lower than they are today. Their models revealed a lost world, a vast continental shelf around Australia that was indeed dry land, complete with river valleys and lakes, which was gradually flooded as the Ice Age ended. The precise details in the Aboriginal stories describing the old coastline and specific geographical features matched the scientific reconstructions with stunning accuracy. These narratives had preserved a memory of the landscape from over 7,000 years ago, a feat of oral history that challenges our very understanding of how long knowledge can endure. On the other side of the world, a different kind of cataclysm was being remembered. Norse mythology contains the gripping tale of Fimbulwinter, a great winter that lasts for 3 years with no summer in between, a period of extreme cold and darkness that serves as the precursor to Ragnarok, the end of the world. For centuries, this was read as a classic apocalyptic myth. Then, in the 1990s, ice core samples drilled from the Greenland ice sheet revealed a startling climatic event around the year 536. Sulfate deposits pointed to a massive volcanic eruption, possibly in Iceland or North America, so powerful it ejected colossal amounts of ash and aerosols into the stratosphere. This veil of particles circled the globe, blocking sunlight and plunging Europe, and likely the Norse homelands, into a period of prolonged cold, crop failure, and famine that lasted for years. The timing aligns with archaeological evidence of societal collapse and migration. It appears the myth of Fimbulwinter is not pure fantasy, but a cultural memory of a real, devastating volcanic winter that traumatized the population, an event so catastrophic it was woven into their most fundamental stories about the end of days. Perhaps the most spectacular validation of ancient knowledge is found in the open ocean. When European explorers first encountered Polynesian voyagers in the vast Pacific, they were baffled. How could anyone navigate this trackless ocean, the largest body of water on Earth, in double-hulled canoes without maps, compasses, or sextants? The answer was a sophisticated science of wayfinding, passed down through chants and oral teachings. Polynesian navigators used a mental star compass, memorizing the rising and setting points of hundreds of stars. They read the subtle patterns of ocean swells, feeling how they rocked the canoe to discern direction and the proximity of unseen islands. They watched for specific species of birds, knowing their flight ranges would point the way to land. They observed cloud formations and the color of the water. To European minds, this was mystical intuition. But when modern researchers like the Hawaii-based Polynesian Voyaging Society began to relearn and test these techniques, they found them to be exceptionally accurate and reliable. The Hokulea, a replica of a traditional voyaging canoe, has successfully sailed across the Pacific multiple times using only these ancient methods, proving they are not myth but a complex, empirical system of non-instrument navigation, a science of the sea that was preserved entirely through oral tradition. These convergences force a dramatic shift in perspective. They challenge the arrogant notion that pre-literate societies were unscientific or that their myths were mere fantasies. Instead, we see that they were brilliant observers of their world. They lacked our technology and our specific vocabulary, but they possessed a deep, practical understanding of their environment. Myth was their database, their textbook, and their hard drive. By wrapping vital information in a compelling story, with characters, drama, and moral lessons, they ensured it would be remembered, recited, and passed down with remarkable fidelity for hundreds, sometimes thousands of years. The story was the vessel and the cargo was truth. This doesn't mean every myth is a literal history lesson, but it does mean we should listen to them with new respect, as potential repositories of long-term environmental data and cultural memory. Each time science rediscovers a truth that was held in an ancient story, it's a powerful reminder that human curiosity and intelligence are not modern inventions. They are our oldest tools, and sometimes the most enduring findings are not written in data, but in legend. The stories our ancestors told about the stars were never confined to the campfire or the ancient temple. They were always meant to travel, to evolve, and to find new life in the hearts and minds of every generation. Today, that journey continues on the silver screen, in the pages of novels, and across our digital devices, where celestial myths have been reborn as the foundational blocks of our most beloved modern stories. Think of the opening crawl of Star Wars, that iconic text receding into a sky full of stars, immediately evoking an epic sense of a vast, ancient conflict playing out on a galactic stage. The franchise doesn't just use space as a backdrop, it is steeped in the language of myth. It gives us a hero's journey straight from the Joseph Campbell playbook, a cosmic force that binds everything together, and even a celestial prophecy of a chosen one who will bring balance. Direct echoes of the divine destinies and cosmic balances found in myths from every corner of our world. It's a space opera, yes, but it's also a powerful reminder that the questions of good versus evil, the search for identity, and the pull of destiny are stories we will always tell, whether we set them in a distant past or a galaxy far, far away. This reinvention of myth for a contemporary audience often involves a brilliant fusion with cutting-edge science, creating narratives that are both intellectually thrilling and deeply human. Christopher Nolan's Interstellar is a masterclass in this blend. The film presents a black hole gargantua not as a simple monster to be feared, but as a terrifyingly beautiful and complex gravitational phenomenon. The screenplay, developed with physicist Kip Thorne, strives for scientific accuracy in its depiction of time dilation and the warping of space-time. But it then uses that hard science as a launchpad for a profoundly mythological idea, that love could somehow transcend dimensions, and that a bookshelf behind a singularity could become a conduit for a father to communicate with his daughter across time and space. It takes the cold equations of relativity and dares to ask if there are forces in the universe that our science cannot yet measure, but our stories have always hinted at. This is not a rejection of science, but an expansion of it into the realm of human emotion, suggesting that the ultimate mysteries of the cosmos might be intertwined with the mysteries of our own hearts. Literature, too, has become a fertile ground for this cosmic dialogue, where old gods walk alongside modern humanity, forcing us to question what we believe in. Neil Gaiman's American Gods is perhaps the quintessential example, exploring the idea that deities are literally brought into existence and sustained by human belief. The novel asks a staggering question: if we stop believing in the old gods of thunder and media and start believing in the new gods of technology and globalization, what happens to the cosmic order? It's a concept that would feel perfectly at home in an ancient creation myth, but it's framed through the lens of a cross-country road trip in modern America. Similarly, authors like Ted Chiang, in stories like Tower of Babylon and The Story of Your Life, use scientific and cosmological concepts as the starting point for exploring age-old philosophical questions about language, perception, and humanity's place in the universe. His work demonstrates that the gap between a telescope and a parable is much smaller than we might think. Both are tools for trying to comprehend the incomprehensible. This persistent presence of cosmic themes across all forms of media does more than just entertain us. It creates a shared cultural language, a common tapestry of stories and symbols that allows us to collectively grapple with the biggest questions. When we watch a character stare into the abyss of a black hole or plead with a forgotten moon goddess, we are participating in a conversation that is thousands of years old. We are using these modern myths to process our own anxieties about technology, our place in a vast universe, and the search for meaning in an increasingly complex world. These stories make the cosmos feel personal and accessible, transforming distant astrophysical phenomena into landscapes for adventure and metaphors for our own lives. They remind us that looking up at the stars has never been a passive act. It is an act of creation, one that invites every single one of us to find our own story written in the light. There is a profound and deeply personal magic that happens when you simply lie back on a cool patch of grass, far from the city's glow, and let your eyes adjust to the true darkness of the night. This act, stargazing, is the most direct and democratic portal we have to the celestial enigmas we've been exploring. It requires no special equipment, no advanced degree, just a willingness to look up and be humbled. In that moment, you are participating in the oldest human tradition, gazing at the very same stars that once guided Polynesian voyagers across an ocean, that inspired Greek poets to tell tales of heroes, and that signaled the Nile's flood to ancient Egyptian priests. You are not just an observer, you are the latest participant in a conversation that spans all of human history, a conversation written in light. To begin this journey, the first and most important step is simply to find darkness. Light pollution from our cities and towns has sadly washed out the night sky for millions of people, creating an orange haze that obscures all but the brightest stars. Seeking out a dark sky location, like an official international dark sky park or even just a remote countryside field, is like removing a veil. Suddenly, the sky is not a blank, black ceiling with a few pinpricks. It transforms into a deep, three-dimensional tapestry, brimming with countless stars, the hazy band of the Milky Way, and the possibility of a streaking meteor. This search for darkness isn't just about a better view, it's a form of time travel, allowing you to see the heavens as every one of your ancestors did. Once you've found your spot, let go of the pressure to know everything at once. Start with just one or two of the most iconic constellations, the celestial landmarks that can guide you to everything else. For those in the Northern Hemisphere, the Big Dipper, part of Ursa Major, is the perfect starting point. Its familiar saucepan shape is visible year-round, and its two pointer stars famously lead your eye directly to Polaris, the North Star. Once you've found that fixed point in the sky, you have your anchor. From there, you can begin to trace the stories. In the winter, look for the mighty Orion the Hunter with his distinctive belt of 3 stars. Knowing that the fuzzy patch in his sword is the Orion Nebula, a stellar nursery where new suns are being born, transforms that little smudge from a blur into a cosmic event happening in real time, over 1,000 light-years away. This is where technology can become a wonderful ally, not a distraction. A good stargazing app on your phone, used with the screen dimmed to red light to preserve your night vision, can act like a personal guide. You can hold it up to the sky and it will overlay the names of constellations, planets, and deep sky objects right over what you're seeing. But the true enrichment comes from diving into the mythology behind these patterns. After you've found Cassiopeia's distinct W shape, read the story of the vain queen who was chained to her throne in the sky as punishment. When you locate the bright star Vega, learn about the Chinese legend of the Weaver Girl, separated from her beloved by the Milky Way and only allowed to reunite once a year. These stories add a rich human layer to the pinpoints of light, turning the sky from a random scatter into a grand, epic storybook. This personal engagement does more than just educate. It fundamentally changes your relationship with the universe. Abstract facts from a documentary become lived, felt experiences. You're no longer just hearing that light takes time to travel. You're seeing it with your own eyes when you look at the Andromeda Galaxy, knowing that its photons began their journey 2.5 million years ago when early humans were first walking the Earth. This visceral understanding fosters a powerful sense of perspective, a gentle reminder that your worries and daily struggles are happening on a tiny, fragile world orbiting an average star in the outskirts of a galaxy that is one of billions. It's not a diminishing feeling, but a liberating one, a connection to something vast and eternal. Ultimately, this practice naturally inspires a desire for preservation. When you have felt the awe of a truly dark sky, you become acutely aware of the orange glow stealing that experience from others. You become an advocate for dark sky initiatives, for using shielded, downward-facing outdoor lighting, and for protecting these windows to the universe for future generations. Stargazing is the bridge that connects our ancient sense of wonder with our modern scientific understanding, and it empowers each of us to become stewards of the night, ensuring that the cosmic storybook remains open for all who wish to read it. Our journey to understand the cosmos is accelerating at a breathtaking pace, propelled by a new generation of missions that are less about answering old questions and more about discovering entirely new mysteries we haven't even thought to ask yet. The James Webb Space Telescope is a perfect example. It's not merely a more powerful version of Hubble. It's an entirely new kind of eye designed to see in infrared light, which allows it to peer through cosmic dust clouds and look further back in time than ever before, to the very formation of the first galaxies. It's already revealing that these infant galaxies are brighter, more massive, and more structured than our models predicted, forcing a complete rethink of how the universe assembled itself after the Big Bang. Every stunning image it sends back is a data point that challenges our assumptions, ensuring that the celestial storybook is receiving dramatic new chapters we never saw coming. But the exploration isn't confined to remote observation. We are on the cusp of becoming an interplanetary species. The ambitious multinational efforts to return humans to the moon and establish a sustainable presence there under programs like Artemis are not just about flags and footprints. They are a testing ground, a prologue to the greatest human adventure since we first left Africa, the colonization of Mars. These endeavors are the ultimate fusion of ancient myth and cutting-edge science. The moon has always been a goddess, a symbol of mystery and cycles. Mars has been the god of war, a red omen in the sky. Soon they will be destinations with real people living and working on their surfaces. This transition from celestial symbol to physical landscape is perhaps the most profound shift in our relationship with the heavens since Galileo. We are turning the characters of our oldest stories into real estate. This shift will inevitably give birth to a whole new genre of myth-making. Imagine the moment, likely within our lifetime, when a rover on Mars or a lander on Jupiter's moon, Europa, drills beneath the surface and returns evidence not just of organic molecules, but of actual extant microbial life. The scientific community would erupt, but so would the human imagination. How would we, as a global culture, process this discovery? Would we see it as a cosmic loneliness ended, a universe teeming with possibility? Or would it introduce a new kind of existential anxiety, a Copernican revolution for biology? We would instantly begin to craft stories around it. Is Martian life our cousin, suggesting a common origin via meteorites, a concept called panspermia? Or is it a second, independent genesis, a completely alien biology that would imply life is not a miracle but a common, even inevitable, chemical process throughout the universe? The discovery would be a scientific fact, but its meaning would be interpreted through a deeply human, and therefore mythological, lens. Alongside these robotic and government-led missions, a new era of accessibility is dawning. Space tourism, while currently the domain of the ultra-wealthy, represents the first faltering steps toward a future where experiencing the overview effect, that profound cognitive shift reported by astronauts who see Earth from space, isn't reserved for a handful of elite explorers. As the technology matures and costs eventually decrease, more and more people may have the opportunity to physically leave our planet and look back upon it, to see the thin, fragile atmosphere and the breathtaking beauty of our world against the blackness of space. This direct, visceral experience has the power to ignite a new global sense of planetary stewardship and wonder, mirroring the awe that ancient stargazers must have felt. It democratizes the cosmic perspective, potentially creating a new global mythology rooted in unity and environmental responsibility. The dialogue between science and story is therefore guaranteed to continue, but it will evolve in fascinating ways. The new myths won't be about gods dragging the sun across the sky. They will be about the first child born on Mars and what her citizenship might be, or the ethical protocols for interacting with a non-intelligent alien ecosystem. They will be stories of generation ships traveling for centuries to reach another star, and the cultures that might develop aboard them. Our tools are giving us the power to not just observe the universe, but to actively participate in its story. Every new discovery from a telescope, every footprint on a new world, is a spark for 1,000 new narratives, proving that our need to weave meaning from the cosmos is as infinite as space itself. There's a profound and deeply personal reason why these ancient stories of the cosmos continue to resonate with us, even in our age of scientific enlightenment. It isn't just about the stories themselves, it's about how they make us feel. When we hear a tale about a constellation being a great hunter placed in the stars or a comet being a messenger of the gods, we are tapping into something fundamental within our own psychology, a primal need for meaning, for connection, and for a sense of awe that lifts us out of our everyday concern. These celestial myths are more than just primitive explanations. They are emotional frameworks, carefully crafted over millennia to help our minds process something that is otherwise too vast, too powerful, and too incomprehensible to grasp directly. They give the infinite universe a human face and a relatable narrative, allowing us to feel a sense of place and purpose within the grand, and often intimidating, scheme of existence. This feeling has a name in modern psychology: awe. Awe is that overwhelming sense of wonder and amazement we experience in the face of something vast that transcends our current understanding of the world. It's the emotion you feel when you stand at the edge of the Grand Canyon, listen to a symphony that gives you chills, or, most relevantly, look up at a perfectly clear, star-filled night sky far from city lights. Studies have shown that experiencing awe has remarkable effects on us. It can make us more humble, reducing our focus on ourselves and making us feel like part of a larger whole. It can make us more curious and open to new information, and it can even make us more generous and connected to others. This isn't a new phenomenon. It's a deep-seated part of what makes us human. The ancient myth-makers were, in effect, the first psychologists, intuitively understanding that these grand stories about the cosmos were a powerful tool for eliciting this awe and helping their communities navigate the emotional impact of the sublime. We now have a powerful modern parallel for this ancient experience, the overview effect. This is a term coined to describe the profound cognitive shift reported by astronauts when they view Earth from space. Seeing our planet as a fragile, blue marble suspended in the black void without borders or divisions often triggers an overwhelming sense of connection to all of humanity and a deep urgency to protect our shared home. They report feelings of awe, humility, and a startling clarity about what truly matters. This transformative experience is a perfect, real-world example of the same psychological principles at work in our oldest myths. The cosmic perspective, whether gained through a rocket ship or a story about the Milky Way being a river of souls, has the power to shake us out of our narrow, individual concerns and reconnect us with something much larger than ourselves. It satisfies a deep hunger for meaning that pure data alone cannot provide. This explains the incredible endurance of these stories. A scientific fact can become outdated, a mathematical model can be refined. But a myth that successfully channels our sense of wonder and helps us process the awe of existence is timeless. It endures because it speaks to the emotional and psychological core of who we are, not just to our intellectual curiosity. It answers the why in a way that resonates with our hearts, not just the how that satisfies our minds. This is why we still point out Orion to our children, why we still feel a thrill at the sudden streak of a meteor, and why the image of a black hole can feel as mythic and terrifying as any ancient dragon. Our brains are wired for story, and the greatest story ever told is the one written in the stars. Recognizing this psychology doesn't diminish the myths, it deepens our appreciation for them as essential tools for human well-being, tools that are now being rediscovered and repurposed in a surprising and effective way. The modern classroom. Imagine trying to explain the sheer, raw power of the sun to a classroom of restless students. You could list the statistics: a core temperature of 27 million degrees Fahrenheit, nuclear fusion converting hydrogen into helium, the release of energy that takes 100,000 years to travel from the center to the surface. The numbers are staggering, but they can also feel distant and abstract. Now, instead, begin with a story. Tell them about Phaethon, the headstrong son of the sun god Helios in Greek mythology, who begged his father to let him drive the celestial chariot of the sun across the sky for just one day. Despite his father's warnings, Phaethon took the reins, but he quickly lost control. The horses, sensing his weakness, bolted from their path, flying too close to the earth and scorching the land, creating the deserts of Africa and freezing other parts by flying too far away. To prevent total catastrophe, Zeus was forced to strike the boy down with a thunderbolt. This gripping tale of hubris and cosmic power instantly captures the imagination. It creates a visceral, emotional understanding of the sun's immense and dangerous energy long before a single equation is written on the board. The myth provides the emotional hook, the science provides the breathtaking explanation. This is the magic of teaching science through story. This pedagogical approach, often called narrative-based learning, is far more than just a clever trick. It is rooted in the very way our brains are wired. Cognitive science tells us that humans are not primarily logical processors, we are storytelling creatures. Our minds are exceptionally good at absorbing, retaining, and recalling information when it is packaged within a narrative structure. A list of facts is easily forgotten, but a story with characters, conflict, and consequence creates a mental framework, a schema on to which new information can be hung. The myth of Phaethon provides the perfect schema for understanding solar physics. After the story has set the stage, a teacher can seamlessly transition into the science, the sun's immense gravitational pull, the process of nuclear fusion that powers it, and the delicate balance that maintains its stable journey across our sky, a balance so precarious that Phaethon's wild ride serves as a powerful metaphor for what would happen if that balance were lost. The story makes the science memorable, and the science, in turn, makes the story more meaningful. This method transforms the traditional learning environment. In a planetarium, this fusion of myth and science becomes a truly immersive experience. Instead of a simple star talk, the dome can come alive with the constellations of the Greek heroes, their stories projected across the ceiling. The audience follows the narrative of Perseus rescuing Andromeda, and then, as the story concludes, the view seamlessly zooms into the specific stars within those constellations. The presentation can reveal that the faint smudge in Andromeda is not a cloud but an entire galaxy 2.5 million light-years away, and explain how we know that. Interactive apps take this even further, allowing students to manipulate a digital version of the solar system, reenacting Phaethon's disastrous path and seeing the temperature changes on a virtual Earth in real time. These tools don't just tell students the facts, they allow them to experience the consequences of the story, solidifying the scientific principles through interactive engagement. Furthermore, this approach does a tremendous service to both fields of knowledge. For science, it demystifies complex concepts and broadens appeal, drawing in students who might otherwise be intimidated by physics or astronomy. It provides an accessible on-ramp to STEM fields, building confidence and curiosity. For the humanities, it rescues mythology from being relegated to dusty old books and repositions these ancient stories as the vital, foundational texts of human curiosity that they are. It teaches cultural literacy alongside scientific literacy, showing students that the quest to understand the universe is a universal human endeavor that connects us across time and culture. A lesson on navigation becomes infinitely richer when it pairs the science of using Polaris to find true north with the Polynesian star charts that guided voyagers across the entire Pacific Ocean. The student learns not just a navigational technique, but a profound respect for the sophisticated knowledge systems developed by ancient cultures. Ultimately, teaching science through story is about building bridges. It bridges the gap between the arts and the sciences, demonstrating that they are not opposing forces but complementary ways of understanding our world. It bridges the gap between the ancient and the modern, showing how our ancestors' first attempts to explain the cosmos laid the groundwork for our current scientific marvels. And most importantly, it bridges the gap between a student and a seemingly distant, complex subject, transforming it from a list of facts to be memorized into an ongoing, epic story in which they, too, can play a part. By honoring the stories of the past, we inspire the scientists of the future, ensuring that the next generation will not only understand the equations, but will also feel the wonder that drives all true discovery. This journey through the stories of the stars is more than an academic exercise. It is a form of cultural exploration that demands respect, humility, and a conscious effort to avoid the pitfalls of appropriation. When we share a Greek myth about Orion, it feels like recounting a tale from a distant classical past. But for many indigenous cultures, their celestial stories are not relics of history. They are living, breathing traditions, integral to their identity, language, and connection to the land and sky today. Treating these narratives as simple folklore or, worse, repackaging them for entertainment without context, strips them of their power and meaning. It reduces a sacred cosmology to a trivial anecdote, which is a profound disservice to the people for whom these stories are a vital link to their ancestors and their future. Ethical engagement means recognizing that we are not just sharing stories, we are handling the cultural heritage of a living people. The cornerstone of this respectful approach is collaboration and consent. This means actively seeking out and amplifying the voices of the communities who own these stories, rather than speaking for them. A powerful example is the work being done to revitalize indigenous astronomical knowledge. Projects are now emerging where astronomers and anthropologists partner with native elders, not to extract information, but to support communities in reclaiming and preserving their own star knowledge. In Australia, this might involve working with Aboriginal custodians to document songlines that were disrupted by colonization. In North America, it could mean collaborating with Lakota educators to develop planetarium shows that present their constellation stories alongside Western astronomy, told from their perspective. This process ensures accuracy, but more importantly, it honors the stories as part of a continuous cultural practice, not as curiosities to be collected and displayed. This ethical framework ultimately enriches our understanding for everyone involved. It moves us beyond a single, monolithic narrative of the cosmos and into a vibrant multiverse of human experience. By acknowledging there are multiple ways of knowing the empirical, data-driven path of science and the spiritual, narrative-based path of cultural tradition, we don't have to choose one over the other. We can hold them together. Science gives us the physical mechanics of an eclipse. A Navajo story gives us the perspective of the sun and moon as male and female beings momentarily reuniting, a time for quiet reflection and renewal. One explains the how, the other explores the why and the meaning. Together, they provide a far more complete and beautiful picture, demonstrating that these different forms of knowledge can coexist, inform one another, and deepen our collective sense of wonder. This mindful approach transforms us from passive consumers of myth into active participants in a respectful, global dialogue. It encourages us to always ask questions about the stories we encounter. Who does this story belong to? What does it mean to them? How can I share it in a way that honors its origins? This practice fosters a more inclusive and holistic appreciation for humanity's relationship with the cosmos, ensuring that the ancient light from these stories continues to shine with its intended power and purpose for generations to come. This deep, respectful engagement with narrative naturally flows into another profound human endeavor, where the mysteries of the cosmos are translated not into words, but into color, sound, and form. There is a unique and powerful form of understanding that bypasses equations and data, speaking directly to the human spirit through color, melody, and form. Long before we had the language of astrophysics, we were trying to make sense of the cosmos through art and music, translating the overwhelming awe of the night sky into something we could feel in our bones. This creative impulse is a vital thread in the tapestry of the Celestial Enigma, proving that our response to the universe is not purely intellectual, it is profoundly emotional, and it demands expression. When a painter tries to capture the swirling violence of a star's birth or a composer attempts to sonify the silent, graceful dance of planets, they are engaging in the same quest for understanding as the ancient myth-makers and the modern scientists. They are just using a different dialect in the universal language of wonder. We can see this dialogue between observation and emotion most vividly in the work of Vincent van Gogh. His iconic painting, The Starry Night, was created in 1889 from the window of his asylum room in Saint-Rémy-de-Provence. This was not a photorealistic depiction of the sky that night. It was an emotional and spiritual interpretation. The stars are not static points of light but great, burning whirlpools of energy. The sky itself is a living, turbulent river of blue and gold, while a serene village sleeps below, oblivious to the cosmic tempest raging above. Van Gogh was capturing a truth that science would later confirm, that the cosmos is dynamic, energetic, and full of movement. His swirling brushstrokes seem to presage the very spiral structures of galaxies and the turbulent physics of nebulae that telescopes would reveal a century later. The painting is a perfect fusion of deep personal feeling and an intuitive grasp of cosmic reality, proving that art can often feel truer than a photograph because it conveys the emotional weight of what we see. Music, the most abstract and atmospheric of arts, has proven to be a particularly powerful medium for conveying the scale and character of the cosmos. The British composer Gustav Holst's monumental orchestral suite, The Planets, composed between 1914 and 1916, is the definitive example. Holst was not an astronomer, he was an astrologer, and his work is a musical journey through the astrological, not astronomical personalities of the planets. Mars, the bringer of war, opens with a terrifying, relentless 5/4 rhythm, a musical depiction of mechanized warfare that feels both ancient and eerily modern. Venus, the bringer of peace, responds with soothing horns and floating harps, while Saturn, the bringer of old age, unfolds with a slow, inevitable march towards a serene conclusion, conveying the peaceful acceptance of time's passage. Holst wasn't trying to write scientific program music. He was translating the mythological and astrological associations of the planets into overwhelming sensory experiences. His genius was in making the cosmic feel personal, giving an auditory body to the gods that the planets were named for, and in doing so, his music has kept these mythological ideas pulsating in our cultural consciousness for over a century. This tradition of cosmic inspiration is not confined to the past. It is exploding with new vitality in the modern era, fueled by the actual data and imagery returned by our telescopes. Contemporary artists like the digital painter Lynette Cook create breathtaking visions of exoplanets orbiting distant stars, based directly on scientific models of their likely atmospheres and geology. Her work is a form of speculative realism, a bridge between the known facts and the imagined landscapes. Similarly, composers are now using science as their score. The data sonification projects undertaken by NASA and various universities transform scientific data into sound. The radio emissions of a planet, the light curve of a pulsar, or the particle impacts on a spacecraft detector are converted into musical notes, rhythms, and harmonies. We can now literally listen to the solar wind or hear the echo of a meteor shower. This isn't music about space, it is space itself, translated into a form our ears can understand, creating a haunting and entirely new way to experience the universe. This incredible output of art and music does more than just decorate our understanding. It performs a crucial function in the human relationship with the cosmos. Most people will never operate a telescope or understand the mathematics of general relativity, but they can be moved to tears by the deep blues of a nebula in a Hubble image or feel a shiver of awe listening to the otherworldly chords of a space symphony. These creative works are the primary gateway to wonder for millions. They keep the celestial enigma alive in the public imagination, fostering a sense of connection and curiosity that is essential for supporting scientific exploration. They remind us that the cold, hard vacuum of space is also a place of stunning beauty and profound mystery, and that to fully appreciate it, we need both the sharp focus of the scientist's eye and the wide-angle lens of the artist's soul. This creative dialogue ensures that our journey to understand the universe remains a deeply human one, engaging not just our minds but our hearts. To truly grasp the depth of celestial enigmas, we must step beyond the boundaries of any single discipline and embrace a conversation between all ways of knowing. Viewing the cosmos solely through the lens of modern astronomy is like listening to only one instrument in a grand symphony. You might follow the melody, but you'll miss the rich harmony created by the entire orchestra. The most complete understanding emerges when we allow science, history, anthropology, and literature to speak to one another, each revealing a different facet of the same magnificent truth. This interdisciplinary approach doesn't dilute the rigor of scientific inquiry. It enriches it by providing context, meaning, and a profound connection to the human journey. It acknowledges that a supernova is both a catastrophic astrophysical event and a historical marker that may have been recorded as a divine omen by a long-vanished culture, and both of those truths are essential to the whole story. This powerful synergy is beautifully illustrated in the field of archaeoastronomy, where ancient records become invaluable scientific data. For centuries, Chinese court astronomers meticulously documented every celestial event they witnessed, from the predictable paths of planets to the shocking appearance of guest stars, what we now know were supernovae. These detailed chronicles, written on bamboo strips and later on silk, were intended to advise the emperor on matters of state, based on the belief that the heavens reflected the ruler's virtue. Today, modern astrophysicists scour these very same records. The detailed description of a supernova observed in 1054 AD, for instance, allows them to pinpoint the event and study its remnant, the Crab Nebula, with a precise historical timeline. Those ancient scribes, seeking to understand the will of the gods, inadvertently created a 5,000-year-long dataset that now helps us understand the life cycle of stars. The myth-inspired observation and the data-driven analysis, once seemingly opposed, now work in perfect tandem to unlock the secrets of the cosmos. Similarly, the rich tapestry of global mythology offers a unique window into the values, fears, and intellectual frameworks of past societies, a perspective that pure astronomy could never provide. When we compare how different cultures interpreted the same constellation, we are doing more than just comparing stories. We are engaging in a form of cultural anthropology. The Greek story of Orion as a boastful hunter killed by a scorpion speaks to themes of hubris and divine punishment central to their worldview. The Lakota interpretation of those same stars as a bison, a central figure in their spiritual and physical survival, reflects a deep reverence for the animals that sustained their way of life. By studying these narratives through an anthropological lens, we learn less about the actual stars and more about the people who looked up at them. The sky becomes a mirror, reflecting not light but the soul of humanity itself. This understanding fosters a deep respect for the diversity of human thought and the many valid ways there are to find meaning in the universe. Literature and art, in turn, provide the emotional and philosophical bridge that connects cold data to human experience. The equations of orbital mechanics can tell us the exact timing of an eclipse, but they cannot convey the sheer terror and awe that our ancestors felt witnessing the sun disappearing at noon. For that, we need the epic poems, the creation myths, and the cave paintings that attempted to process that overwhelming emotion. When we read a Navajo story that describes an eclipse as the sun and moon momentarily reuniting in a sacred embrace, we are granted access to a worldview that sees the cosmos as a place of relationship and renewal, not just cold, empty space. This literary perspective doesn't contradict the science, it complements it by answering a different kind of question. Science explains the mechanism, but story explains the meaning. Together, they satisfy both our intellectual curiosity and our deep-seated need for narrative and connection. Ultimately, This blended way of learning does more than just give us a richer past. It points toward a more engaged and curious future. It encourages a form of lifelong learning that is not confined to textbooks or laboratories but is alive in every dark sky we look up at, every old story we read, and every museum artifact we ponder. It invites the amateur stargazer to learn the mythology of the constellations they are identifying. It encourages the history buff to understand the astronomical events that influenced the decisions of ancient kings. It empowers everyone to become a part of this ongoing human conversation with the cosmos, contributing their own unique perspective and curiosity. By breaking down the artificial walls between disciplines, we open ourselves up to a more holistic, compassionate, and truly awe-inspiring understanding of our place in the universe, where every question leads not to a single answer, but to a deeper and more wonderful mystery. And so we reach the end of our journey, a voyage that has taken us from the campfires of our ancestors to the cutting-edge day, to streaming from the James Webb Space Telescope. We've seen how a single eclipse could be a dragon to one culture and a divine reunion to another, how the same stars could form a hunter, a canoe, or a great bear, depending on the eyes that traced their patterns. We've watched as the telescope shattered a crystal celestial sphere to reveal a dynamic universe of star birth and black holes, and we've seen how our most advanced probes have not diminished the wonder, but have instead revealed a cosmos far more strange and magnificent than any myth could have conceived. This is the beautiful, enduring paradox of the celestial enigma. Science does not replace mystery, it reframes it, trading smaller questions for grander, more profound ones. We no longer wonder what kind of dragon eats the sun, but we are left utterly humbled by the precise cosmic clockwork that allows such a perfect alignment to occur, and we are driven to ask what laws of physics govern the entire, breathtaking dance. This dialogue between story and science is not a thing of the past. It is the very engine of our curiosity. Every time a scientist gives a black hole a name like Gargantua, they are tapping into that ancient, myth-making part of our brain. Every time a writer uses a wormhole as a plot device, they are participating in a tradition that stretches back to tales of heroes descending into the underworld. Our need to narrate the universe is as fundamental as our need to understand its mechanics. They are not opposing forces but two essential languages we use to converse with the cosmos. One gives us the equations for gravity, and the other gives us the metaphor of a curved tapestry of space-time. Both are trying to describe the same incredible reality. Embracing the celestial enigma means becoming fluent in both languages, allowing the data to deepen the wonder and the wonder to inspire the next scientific question. So the next time you find yourself under a clear night sky, I invite you to try this dual vision for yourself. Don't just see the Big Dipper, see the Great Bear being chased by hunters, and also know that you're looking at a snippet of our galactic neighborhood, with each star at a vastly different distance from our own. Find Orion and know that the faint smudge in his sword is both the glowing sword of a mighty hunter and the Orion Nebula, a stellar nursery where new solar systems are being forged from cosmic dust. This layered view doesn't complicate the experience, it enriches it, connecting you to every human who has ever looked up in awe and asked what it all means. You become part of that timeless conversation. I would love to hear how this journey has resonated with you. Do you have a favorite constellation or a celestial story passed down in your family? Have you ever witnessed an eclipse or a meteor shower that left you speechless? Share your own experiences and thoughts in the comments below. Let's continue this conversation together. If you've enjoyed unraveling these mysteries with me, please subscribe to the channel and hit the notification bell so you don't miss our next adventure into the unknown. If you've enjoyed unraveling these mysteries with me, please subscribe to the channel and hit the notification bell so you don't miss our next adventure into the unknown. From all of us here, thank you for your time, your curiosity, and for sharing this celestial adventure. Keep looking up and never stop wondering.